Irreducible complexity was coined by Behe in describing these molecular machines. Basically what it says is that you have multi-component parts to any given organelle or system in a cell, all of which are necessary for function. That is, if you remove one part, you lose function of that system.
The idea of irreducible complexity can be illustrated by a familiar, non-biological machine, a mousetrap. The trap is composed of 5 basic pieces: a catch to hold the bait, a strong spring, a thin bent rod called the hammer, a holding bar to secure the hammer in place, and a platform upon which the entire system is mounted. If any one of these parts is missing or defective, the mechanism will not work. All components of this irreducibly complex system must be present simultaneously for the machine to perform its function, catching mice. Irreducible complexity also applies to biological machines, including the bacterial flagellar motor.
All told, there are about 40 different protein parts which are necessary for this machine to work. And if any of those parts are missing, then either you get a flagellum that doesn't work because it's missing the hook or it's missing the drive shaft or whatever, or it doesn't even get built within the cell.
In evolutionary terms, you have to be able to explain how you can build this system gradually when there's no function until you have all those parts in place.
The irreducible complexity of molecular machines poses a severe challenge to the power of natural selection. According to Darwin's theory, even very complex biological structures like an eye, an ear, or a heart can be built gradually over time in small incremental steps. Yet, as Darwin made clear, natural selection can only succeed if these random genetic changes provide some advantage to the evolving organism in its struggle for survival.
As I have attempted to show, it is not necessary to suppose that the modifications are all simultaneous if they were extremely slight and gradual. Natural selection is scrutinizing the slightest variations, rejecting those that are bad, preserving and adding up all that are good.
But could Darwin's small, favorable variations have produced a bacterial flagellum? Some scientists doubt the possibility.
How could something new, like a bacterioflagellar motor and all the components that go with it, how could it develop out of a population of bacteria that don't have that system? When each change, according to Darwin's theory, has to provide some kind of advantage.
Imagine such a scenario early in the Earth's history. An evolving bacterium somehow develops a tail and perhaps even the pieces necessary to attach it to the cell wall. Yet without a complete motor assembly, this innovation would provide no advantage to the cell. Instead, the tail would lie immobile and useless, invisible to natural selection, which by definition can only favor changes that aid survival.
The logic of natural selection is very demanding. Unless the flagellum mechanism is completely assembled and actually works, natural selection simply cannot preserve it. It cannot be passed on to the next generation.
The important thing to realize about natural selection is it selects only for a functional advantage. In most cases, natural selection actually eliminates things that have no function or that have a function that harms the organism. So if you had a bacterium with a tail that didn't function as a flagellum, chances are natural selection would eliminate it. The only way you can select for a flagellum is if you have a flagellum that works, and that means you have to have all the pieces of the motor in place to begin with. So natural selection can't get you the bacterial flagellum. It can only work after the flagellum is there and operating.